In this section, we're going to be going through actual proton NMR spectra, and we'll be looking at the various spectra, and from that and a molecular formula, we're going to deduce organic structures. So let's start with this first example. We're given a molecular formula C7H8O and the proton NMR spectrum. The first thing you want to do anytime you're given a molecular formula is calculate the number of unsaturations. So if you need to review that, you can go back where we did unsaturation calculations and review how to do those. But for this, if you do the calculation, you should find that there's 4 unsaturations. So that means we have some combination of double bonds, rings, or triple bonds to give us our 4 unsaturations. Now from here, I like to typically work my spectrum from left to right. And what I like to do is go through and figure out the different regions that we have. So right here in this 7 to 8 region, if we pull up our table of typical regions, right here in the 6.5 to 8 region, that's the aromatic region. And that's what we have right here. So what we're going to do is, with this being the aromatic region, and we see this integration for 5 hydrogen, that should immediately click that this is a monosubstituted benzene. So we have this multiplet in the aromatic region, and this monosubstituted benzene has 5 hydrogen. Okay, the next thing, we have an integration for 2 hydrogen. Let's make that a CH2. And an integration for 1 hydrogen. Let's make that a CH. Now, use what you have and check it against your formula. 6 carbons here, plus 1 carbon here, plus 1 carbon here. That's 8. Well, based on our formula, we only have 7 carbons to work with. So we've put 1 too many carbons in the spectrum. Also, if we get our hydrogen count, we have 5 hydrogen, 2 hydrogen, 1 hydrogen. That gives us our 8. But we're still missing an oxygen. So, since we have too many carbons accounted for, what if instead of having a CH, we have an OH? And if that's the case, now we have the right number of carbons, hydrogen, and oxygen. Also, our aromatic ring here has 1 ring and 3 double bonds. That's our 4 unsaturations. So that's taken care of. Now we just need to connect these fragments together. And this one should be pretty straightforward. We have our CH2 carbon. That'll connect to the OH. And it'll connect to the aromatic ring because that CH2 needed 2 bonds. The splitting also works out because the CH2 is a singlet and it's bonded to this aromatic carbon that doesn't have any hydrogen and an OH, which is a heteroatom, so you wouldn't expect any splitting. So we can draw this a little more neatly. We have our aromatic ring, CH2, OH, and there's that structure.